Hello, my name's Evan Reed, and I'm a senior technical writer here at GitLab. And today I wanted to give you a demonstration of Lychee, which is a new tool for us that we're now starting to use for documentation link checking at GitLab. Before we take a look at Lychee, I wanted to just explain why we're beginning to use Lychee and why we're beginning to use it now. So the reason we're using Lychee at all is because we're looking to re-platform our docs site. So the docs site is currently built using Nanoq, and Nanoq was providing us with link checking. Now that we're looking at switching to Hugo, and because Hugo doesn't have built-in link checking, we needed to find an alternative. Now you might ask yourself, well, why now? Why not closer to when the Hugo replatforming goes live? The main reason is to allow us to get some of the benefits of Lychee sooner. The old process with Nanoq is quite slow, and it requires us to publish the documentation before we can check its links, which is always limited where we could put link checking in a contributor's workflow. So Lychee allows us to remove some of those barriers to link checking everywhere. Let's have a look at Lychee itself. So first of all, it'd be worth having a look at some of the options available with Lychee. So Lychee is a simple command line tool. If I call up the help here, you can see that it has a lot of options. So yeah, I won't go through all of them now, but some important ones for us is the ability to check for link fragments, which is where you use a hashtag, you might call it, or an anchor tag to deep link into a file. So we want to be able to check those in case we're renaming sections. We also want to be able to include and exclude certain types of links. We want to be able to sometimes check offline. So we don't want to have to require a network connection to check links. That's one way of speeding up link checking, is to only check local files and to block network requests. For those times where we do want to check external links, we can lower the maximum concurrency of network requests. So if you check links on that point to a server, if you check too many of those links too quickly, you can get rate limited. And that will result in failure of the link checking. So we can reduce it quite substantially so that we're checking links much slower, relatively speaking, but we can keep under a rate limit for a given server. So the benefits of Lychee is that it's very fast. You can check links in minutes. Sorry, you can check links in seconds rather than minutes. And that means that it can be embedded in workflows like a linter. So let's have a look at our first demonstration. This is Lychee set up to check all of the documentation for all of the projects that we publish documentation from. Let's run it. So you can see here that it is so fast that you can run it very regularly in lots of different contexts. And as you could see, it took seconds rather than minutes, which is what the old process takes. The old process could take 5 or more minutes. This is much, much faster. Now, one of the drawbacks of this, though, is that we're checking the pre-published markdown. And sometimes links are valid in pre-published markdown that are not valid once published. For example, if someone wants to link into files outside of a doc directory, that's valid in Markdown, but not valid for Lychee. So we have to catch some of those invalid links a different way. And we've managed to do that using veil rules. So one of our other linters is doing some of the work to catch those invalid links. But as you can see here, we've got a few links that we do want Lychee to catch or that Lychee can catch. Here we've got a few misspelt files, which is why the files could not be found. And here we've got fragments that could not be found because the anchor link or anchor tag or whatever you want to call it, the deep link was misspelt. And you can see here we've checked the GitLab project and another project as well. We've checked many projects, but these are the projects that had errors in them. Now, commonly people won't do this. They will just check the links in one project. So let's have a look at that. Here we've set up to check the links of just the GitLab project, just the docs directory or the doc directory. But we can also check other Markdown files in that project. So here we're also going to check the README file. This is something we've not been able to do before. Our Nanoq-based link checking would only check published documentation. Here, we could theoretically check any Markdown file in the project. And you can see here it's found just the 2 problems that are just for that project. We've checked tens of thousands of links in a very, very short amount of time. You can see here that many links are excluded, and that's just because they're external links or they're excluded for some other reason. But we still were able to check across many, many links, nearly 20,000 links, and we were able to do it incredibly quickly. Now, because we can do it so quickly, we can incorporate it into scripts that are routinely run by contributors, engineers and others. And so here, I've set it up so that we can run the lint-docs link check script, which is wrapped up in a documentation linting script in the GitLab project. And so we'll just run that. And again, it's incredibly fast and it can be run routinely as part of linting other types of linting. So we've got Markdown linting, which is fast and run frequently. We've got Veil linting for prose linting, which is fast and we can run that routinely. And now we've got link checking that we can wrap up in that docs linting script and run that regularly. And another place where we're finally able to include link checking is in Git hooks. So we have a Git hook manager. We use a GitLab called Left Hook. And for anyone that's using Left Hook, we're able to now check links before you push. And this is really great because this means that rather than waiting for a pipeline to break, we can now catch pushes that might contain broken links. So let's run that Left Hook command now. That just does the docs link checking. And so there you are. You can see here that Lychee is very fast, can be run in many different contexts with many different options, and run routinely with very little setup compared to the old process. So that really is the end of the demonstration. What I would suggest you do is go back through the video and see the different ways that I've run Lychee and have a go at running it yourself on different projects, both ones we publish and ones we don't publish. Have a look at all the different ways that you can call Lychee, be it in scripts, be it in Git commit hooks or Git hooks and things like that. And yeah, just get really familiar with it and add it to part of your daily workflow. Thank you.